Three-tier software architecture is a popular design pattern used in the development of software applications. It divides the application into three distinct layers or tiers, each responsible for specific functions and interactions. These tiers are the presentation tier, the application tier, also known as the logic or business tier, and the data tier. Presentation tier. The presentation tier, also known as the user interface (UI) tier, is the topmost layer that interacts directly with the end user. It focuses on displaying information to users and capturing their inputs. This tier includes components such as web browsers, mobile apps, or desktop applications. Its primary responsibility is to provide a user-friendly interface and handle user interactions. The presentation tier communicates with the application tier to process user requests and retrieve data. Application tier. The application tier, sometimes referred to as the logic tier or business tier, resides in the middle layer of the three-tier architecture. It contains the core logic and functionality of the software application. This tier handles the processing of user requests, implements business rules, and coordinates data retrieval and manipulation. It encapsulates the application's business logic, workflow, and algorithms. It serves as an intermediary between the presentation tier and the data tier, translating user actions into meaningful operations and coordinating the retrieval and storage of data. Data tier. The data tier, also known as the persistence tier or backend, is the bottommost layer of the three-tier architecture. It is responsible for managing data storage and retrieval. This tier typically involves databases or file systems where data is stored persistently. The data tier handles tasks such as data validation, storage, querying, and retrieval. It interacts with the application tier to provide and receive data necessary for the application's functionality. The data tier ensures data integrity and security. Each tier in the three-tier architecture has distinct responsibilities and communicates with the adjacent tiers in a controlled and well-defined manner. This separation of concerns allows for modularity, scalability, and maintainability of the software application. It also promotes reusability, as changes made to one tier can have minimal impact on the other tiers. Additionally, the three-tier architecture enables different tiers to be developed independently, allowing for parallel development and easier integration of new features or updates.